In this video we're going to solve an equation involving logs. Here's the equation we're going to solve. Log base 4 of x minus 1 plus log base 4 of x minus 7 equals 2. Now in this red box I have listed some important rules and properties of logs that you need to know before you start solving equations with logs. If you don't have these memorized, you need to memorize them. That's going to make solving equations with logs a lot easier, actually even possible. If you don't know these rules, it's pretty much impossible to solve these equations. Alright, so let's see what we have here. This first line, log base b of m equals x, can be translated into b to the x equals m. This is how you change back and forth from log form to exponential form. The next rule is, what do I do if I have two logs added together? How can I combine those into a single log? The next rule tells us what we can do if we have a log minus another log and how we can combine those together into a single log. And the last rule has an exponent up here of r, and it says I could take this r and bring it down in front and write it like r times log base b of m. And this last rule is really useful when your variable is in your exponent, when this r is the unknown and we know some of the other numbers. Or the variable that you're trying to solve for is in the exponent, let's put it that way. Which is not the case in this current problem right here. Now hopefully you're looking at these rules and you can see which rule we're going to need to apply to this problem. Which one of these rules looks like this problem? Hopefully you're saying it's this second one down right here, the sum of two logs. And I want you to notice that in all these rules, your b value, your base, is the same. So what that's saying is that you can only combine these two logs together if they have the same base, which we do. We have a base 4 in both of our logs. If this was a base, if the first one was a base 4 and the second one was a base 10 or something, we would not be able to use this rule. Okay, but luckily we can. So here's what we're going to do. We're going to combine these together. We're just going to follow this rule, and we're going to combine the right-hand side of our equation into one log. So what do we get? We get the log base 4. So I'm doing this right here. Let me underline it in red. I'm doing this now. I'm doing log base 4 of m times n. So my m value is the x minus 1, and my n value is the x plus 7, and then I have to multiply m times n. Hopefully you see how that pattern is working. So I have log base 4 of x minus 1 times x minus 7. It's the log base 4 of all that equals 2. Well, I have two choices here. I could FOIL this x minus 1 times x minus 7 out, or I could use this first property up here. We're going to have to do both those things, and it really doesn't matter what order. Let's go ahead and multiply that out. That's fine. So what do we get? We get x squared, and then minus 7x and minus 1x will give us a minus 8x, and then a plus 7 equals 2. So now what we have is something in this form right here. Log base b of m equals x. In our b, for our b we have 4. For our m value, we have this trinomial, which is fine, x squared minus 8x plus 7, and our x value is 2. And what we want to do is change it to this form right here, exponential form, and that'll get rid of the log. Then we won't have that log in our equation anymore, and we'll see what it looks like, and I think we'll have some ideas on how to solve it. Okay, so we're going to write it like this. B to the x equals m. Our b value is 4. So 4 to the x, which is our 2, so 4 to the second equals m. And our m value is this big old trinomial. Well, it's not that big. X squared minus 8x plus 7. So now we have a quadratic equation. We're going to square this 4 and get 16. We're really not working with a log equation anymore. We changed it to exponential form. That got rid of the log. And now we have a basic quadratic equation, and we don't really have to worry about the logs until we get our answers and plug them back in and see if they make sense. So when I have a quadratic equation, what I want to do is set it equal to 0, minus 16 from both sides, and then see if I can factor it. If I can't factor it, I'm going to have to use the quadratic formula. But I'm feeling positive that this is going to factor. I only have a 1 in front of my x squared, so I simply have to put two x's there and then figure out what multiplies to be -9 and adds to be -8. And remember, that only works if the coefficient on the x squared term is 1. Probably 9 and 1. Let's see, how about a -9 and a +1? That looks good. Now we set each of these equal to 0 because I have two things that are multiplying together to equal 0. So either x minus 9 has to be 0 or x plus 1 has to be 0. And in the first case, if x minus 9 is 0, then x is 9. If x plus 1 is 0, then x is -1. By simply adding 9 to both sides and subtracting 1 from both sides, I get these two answers. So that's it. Those are our answers. Now, we do have to look back at our equation and plug these back in and make sure that they make sense, because sometimes with certain types of equations like log equations and radical equations, you can get solutions that actually don't work in the original equation. So let's check it out. Let's see. Let me write the original equation over here. We have log base 4 of, let's go ahead and plug in the 9. X equals 9. So let's plug that in and see if it works. Log base 4 of 9 minus 1 plus log base 4 of 9 minus 7 equals 2. That would give me log base 4 of 8 plus log base 4 of 2 equals 2. I'm going to use the rule and combine these together. So I get log base 4 of 8 times 2, which is 16, equals 2, and then convert it to exponential form. 4 squared is 16. That's true. Excellent. The 9 worked. That is definitely a solution to our equation. So I'm going to go ahead and put that in a red box down here. That works. I'm very happy with that. Let's try the -1. So I'm going to plug in x equals -1. Log base 4 of, I'm going to plug in the -1. Log base 4 of -1 minus 1 plus log base 4 of -1 minus 7 equals 2. Now I have log base 4 of -2 plus log base 4 of -8 equals 2. Now, if we do the next step like I did last time and multiply these two negatives together, we're going to get a positive 16 and it's going to end up working. But here is the problem. Let's look at what this is saying right here. Log base 4 of -2. And let's remember what that means. Let's say this is equal to y. So what that means is 4 to the y power equals -2. Log base 4 of 2 is actually representing an exponent. It's asking you 4 to what power is 2? Or excuse me, -2. 4 to what power is -2? Now let's think about that for a minute. How do we take something to a power and get a negative number? How can we do that? If anything to the 0 power is 1. If it's a positive power, it's obviously a positive number. What if it's a negative power? What if you have something to a negative power, like 4 to the -3? Is that a negative number? No, it's not. It's 1 over 4 to the 3rd, which is 1 over 64. So 4 to a negative number is still going to give you a positive number. How do I get it to come out to be a negative? And you're probably anticipating that you can't. Otherwise, I wouldn't be ranting and raving about all this. You can't take 4 to a power and have it come out to be a negative number. There is no solution to that. So this log base 4 of -2 is no value. It has no solution. You can't take something that's not a number and add it to something else that's not a number. That is also no value, and have it come out to be 2. But the reason it worked when we were solving is because we invoked the rule where we multiplied the -2 times the -8, and we sort of canceled those two things out, and that created a solution that didn't work. So x equals -1 has got to go. We can't have that. In general, you could say that if you have log base b of m equals x, m has got to be greater than 0. Alright, so if m comes out to be less than 0, throw that solution out. And the way you have to make sure to plug in your number. Sometimes you could get an x value that's actually positive, but when you plug it in up here, it makes the m value negative. So it's really the m value that you're checking out. Again, the big thing is to memorize those rules. Make sure that those are just second nature when you're starting to solve log equations, and things should go smoothly after that.